Hello, this video is for IXL activity 8.B.4. It is titled Compare and Order Integers. The 3-character code for this activity is Tango to Mike. So in this activity, we're going to be using inequalities to compare numbers. That's what we're asked to do, is to compare numbers, and then we're going to put them in order, sometimes from least to greatest, and then other times greatest to least. So let's take a moment to talk about inequalities. I've kind of brought this graphic along in order to discuss it. The signs that we see here are called inequality signs. Now, you're used to seeing, get my pen here, you're used to seeing equal signs, right? Well, this is an equal sign, and these are inequality signs, meaning that things are not equal. So we know that like 5, 9, and -7, none of those numbers are equal to one another. They're either greater or less than each other. So in this table here, we're going to talk about whenever we graph, and we won't be graphing in this activity, we'll just be putting them in order, but it is kind of helpful to understand the idea of an inequality, and number lines do a really good job of kind of sharing that concept and that idea. An open circle, see how this circle is open, means that the value is not included. So we're talking about any number x and it's greater than 2. So we read this sign as greater than, and over here, this down here, this sign is less than. So we're saying x is greater than 2. So we're talking about any number to the right of 2, because all the numbers to the right of another number on a number line are greater than that number. But 2 is not included. We can't put a 2 there. That would be 2 is equal to 2. So 2 is not included, so we use an open dot on the graph to represent that. Then likewise, less than, so we say x is less than 5. We would read it this way, x is less than 5. So we know that on a number line, all the values to the left of another number are less than that number. So going this way would be all the values that are less than 5. However, we couldn't include 5, so it's an open dot. Now later on in other lessons, we'll talk about what if we could use 3 here. X is less than, or x is greater than or equal to 3. So it could be 3, so we used a closed dot to include that. No need to worry about that for now, just thought I'd share that a little bit there. And then later on we'll talk about interval notations and using symbols, and it looks something like this, but we're not there now. All right, so let's use the concept of a number line in order to put these in order. So if I had a number line, and let me see, I've got some negatives and some positives, so let's put a 0 here and put our positives to the right and negatives to the left. Our positives are 5 and 9. Well, we know we would come to 5 first, and then we would come to 9, going up from 0. Then going back from 0, we'd find -7 back here someplace. And we notice that this is a greater than sign, and it's even telling us from greatest to least. So if we want to go greatest to least, we're going to start over here at the right, and we're going to list our numbers from the right going back to our left. So 9 is greater than 5, and 5 is greater than -7. So we got 9, 5, -7. On the next one here, let's go ahead, use the number line strategy again. And I do have positives and negatives, so I'm going to use a 0. -3 is going to be down here somewhere, so I took care of -3. And then 8 and 6. Well, I would come to 6 first, and then I would come to 8. Now, I know that my intervals aren't really dead on. They're not really proportionately accurate, but I'm not really interested in that right now. I'm just wanting to organize them so that I can list them from greatest to least or from least to greatest. So in this case, I want least to greatest. Notice the less than sign. We're saying this number is less than that number, which is less than that number. So we're going from the least to greatest. So least to greatest is going to be reading them from the left going to our right. So it's going to be -3, then the 6, then the 8. So -3 is less than 6, 6 is less than 8, I have a true statement. Next one here, another number line. I do have some positives and negatives, so I know I need a 0. And I have a negative number, negative 37. And then I have a couple positive numbers. I would come to 51 first. And then I would come at some point to 98. And I'm listing them from least to greatest. So I'm going to start at the left and go to the right. So negative 37. And my next one's 51. And then 98. Let's look at our next ones here. Now we're given 4 values, but we can still use that number line approach. Do I have some positives and negatives? Indeed I do, so I'll use a 0. Let's deal with the positive ones first. 4 and 7. Well, I would come to 4 before I would come to 7. And then my other ones are negative 1 and negative 4. So as I'm going back to the negative numbers, I'd first come to negative 1. Then at some point I come to negative 4. And they want to know greatest to least. This number is greater than that number, is greater than this number, which is greater than this number. So I want to do the greatest ones first, and then go down to the least. So 7 and 4, and negative 1 and negative 4. Number line works pretty well to organize this. Some of you may be able to do it without the number line, which is great. If you can do it without the number line, that's fine. If the number line seems to help you, then I strongly encourage you to use it. So I have a positive 81. That's the only positive number. So that's going to be here all by itself. Now, as I go to negative numbers, I actually want the ones with the lower absolute value, the ones that are closer to 0, right? So I would look at 61, negative 61. Then at some point I would come to negative 85. And then right after that would be, squeeze in there negative 81. I got negative 85. I missed negative 81, didn't I? It's going to be somewhere before that. So negative 81. Took care of that, and then negative 86. So they want it from least to greatest. So I'm going to read from left going to the right. So the first one's going to be negative 86. Then negative 85. And then negative 81, then negative 61, and then finally positive 81. You'll notice that on the opposite side that the absolute values get greater the further you go away from 0. And that makes sense because as you move to the left, the distance from 0 increases. So if you don't really consider the negative signs, we're doing 61, 81, 85, 86, you realize that the absolute values get greater as you move to the left away from 0, just like on the positive side that the absolute values get greater moving from the left to the right from 0. On the next one, here we just need to compare two numbers using inequality statements. So we have a choice of greater than, less than, or equal to. So on this one here, rather than a number line, let's use the concept of absolute value, right? So absolute value of 74, negative 74, excuse me, is going to be positive 74. And the absolute value of negative 80 is going to be positive 80. So which one's furthest away from 0? Well, it would be 80, right? Or negative 80, because it has an absolute value of 80. So in this case, we know that negative 74 is going to be closer to 0. That means it would be to the right of negative 80 on a number line. And I'm going to erase all this clutter there. So we know that in this case, that negative 74 is going to be greater than negative 80. So we're going to use this symbol right here because negative 74 is closer to 0 than negative 80 is. On the next one, which sign makes the statement true? Well, we have 2 and 2. And, well, that's easy enough. We know that these are equal to one another, so we're going to select the equal sign. And our next one here, I was expecting it to go to the word problems. I guess I got a couple more left. So, positive and negative. This is going to be easy. Positive numbers are always greater than negative numbers, so we're going to use the greater sign. 91 is greater than negative 55. And here we have another positive negative situation. We know that all positive numbers are greater than negative numbers, so 9 is going to be greater than negative 8. So we'll select greater than again. All right, now we come to the word problems. Now, it's my experience that students see word problems and all of a sudden they freak out. But let's use a strategy for this. Let's first read through it and see what they're asking. Always make sure you know what it is that they're asking. So the average temperature is negative 29 degrees Celsius in Springdale, 40 degrees Celsius in Ashland, and 32 degrees Celsius in Kensington. Which list shows the cities from coldest to warmest? So colder temperatures are lower than warmer temperatures, so we're kind of looking for what? Least to greatest is another way to look at that. And word problems, especially in IXL, they usually do really good at making sure that they use words that start with different first letters. And let me explain. So let's start at the beginning. The average temperature is negative 29 degrees Celsius in Springdale. Springdale starts with an S, and Springdale is negative 29. So let's take S and relate it to negative 29. Next part, 40 degrees Celsius in Ashland. Ashland starts with an A, so let's make the A have a value of 40. And then finally, negative 32 degrees Celsius in Kensington. So the negative 32 matches up with Kensington, which starts with a K. So we'll let Kensington, we'll represent that with the letter K, and we'll associate the value negative 32. Now we just need to put these in order from least to greatest, and because least to greatest is going to tell us coolest to warmest. So least is going to be the one with the greatest absolute value on the negative side. So that's going to be negative 32. Then we would have the other negative number, negative 29. And then finally, the warmest or the greatest value is 40. So let's put our letters that are associated with each one. Negative 32 gets a K. Negative 29 gets an S. And 40 gets an A. So we're looking for what? Kensington, Springdale, Ashland. Kensington, so it's going to be one of the last two. Springdale, Ashland. So it's this second to the last choice, or what is it? The fifth one down? Kensington, Springdale, Ashland. Another word problem here. At 1 a.m., the temperature was 1 degree Celsius. So 1 a.m. Oh, I should have squeezed that in there. Let me erase a little bit. There we go. So at 1 a.m., it is negative 1 degrees, I guess, Celsius. We'll put the label on there. And at 9 a.m., and we're assuming this is on the same day, it is 7 degrees Celsius. Was it warmer or cooler at 1 a.m.? So they're asking at 1 a.m. what was it? So we're wanting to know right here. They're asking about this. Now it makes sense that it gets warmer as you get further in the day. 1 a.m. is like the middle of the night. 9 a.m. the sun's starting to come up. So it makes sense that it gets warmer. But nonetheless, they want to know, was it warmer or cooler at 1 a.m.? Well, negative 1 is cooler than a positive 7. So we're going to select cooler. This question here, at 10 a.m. the temperature was negative 24. So I'm going to start writing my information there. 10 a.m. and negative 24. At 3 p.m. in the afternoon, it was negative 14. And at 6 p.m., it was negative 26. So I've kind of taken the information out of the paragraph or the sentence form there, and I put it to where I could see it a little more clear. Now let's see what the question is. When was it warmest? Well, out of all these values here, right here, negative 14 has the greatest value. Remember, they're all negative numbers, so the one with the lowest absolute value is going to be closest to 0. The one closest to 0 is going to be the greater of the 3. So we're looking at 3 p.m. is whenever it was its warmest, so we'll select 3 p.m. And this is indeed my last question, so one more word problem. Notice that we have county names this time. So let's try that same strategy. Let's take the numerical information, tie it to its county in this case, and we'll represent those counties. Let's see if we can pull that off using letters. And it looks like we'll be able to, because you notice that our three counties are Fulton, Richmond, and Carroll, and all three of them start with a different first letter, so that really makes it convenient. So looking at that, we'll go with the average temperature is -20 in Fulton, so -20 will associate with the letter F. 77, so let's put our 77 degrees Fahrenheit in Richmond County, so we'll associate 77 with an R, getting that from Richmond. And -24, so grab my -24, and I'm going to associate that with the letter C for Carroll. Now what are they asking? Which list shows the counties from coolest to warmest? So this is going to be least to greatest. So we can use a number line this time because I do have positive and negative numbers. That'll help a little bit. So here's my 0. The positive number is 77, so we'd find it over here someplace, right? And then -20 and -24. Well, if we start from 0 and start going back, we're going to get to -20 first, correct? Then after that, we get to -24. So we want them from least to greatest. So let's take our values and associate them back to those letters that we're using for the counties. So -24 is associated with a C, -20 with an F, and 77 with an R. So we're looking for CFR, or another way to say that is we're looking for Carroll, Fuller, Richmond. And again, it is the fifth answer, second from the end. All right, so those are all my examples for IXL 8.B.4, where we compared and ordered integers. And good luck with your activity.